Hi everyone. Today we're going to learn how to solve quadratics through factoring. So today we're going to work on lesson number 9. For the do now, it says to factor the following expressions. So after yesterday's lesson, you got to review some factoring. Hopefully you got a chance to check Schoology, and you got to review some of these different types of factoring that we've seen before. So let's just jump right into it. Question number 1, it has x squared plus 7x plus 10. Whenever you're factoring, you're always going to look for a GCF first. And in all of these terms, I don't see anything that goes into x squared, 7x, and 10. So this has no GCF. So we can go straight into, whenever we have a trinomial, we could use a shortcut today because there's a 1 in front of the x squared. So we want to figure out what multiplies to 10 and what adds to 7. So think about what multiplies to 10. We've got 1 and 10. We have 2 and 5. And that's it. So yeah, 2 and 5. 2 and 5 will multiply to 10 and add up to 7. So that means we can go straight to our parentheses, x plus 2, and then x plus 5. And if you were to distribute that, you would get x squared plus 7x plus 10. So that is the factored form for the first one. Now, second one's a little different. There isn't a 1 in front. Okay, so we can't use the shortcut in question number 2. We have to multiply 3 times positive 4 and get 12. That's the number we want to multiply to, but still we want to add to a negative 8. So we're going to play that x game, but this time we want to multiply to 12, add to a negative 8. Okay, so what multiplies to 12? Like, start thinking about it. 1 times 12, 2 times 6, 3 times 4. But all of those are positive. So what other numbers multiply to a positive 12? Negatives. Negative 1 and negative 12. Negative 2 and negative 6. Those are it. Those are going to add up to a negative 8. So we can't use the shortcut here. We have to split the middle term into negative 2 and negative 6. So I'm going to put the negative 6 first because that has a GCF with 3. And then the negative 2 second because that'll have a GCF with 4. And then we're going to split the middle. So the GCF of the first two is not just 3, it's 3n, And then what's left over is n minus 2. And then the GCF in the next two would be a negative 2. And what's left over is also n minus 2. And remember, we're looking for what else they have in common. They both have an n minus 2. That goes in front. And then what's left over is the 3n minus 2. And that is our factored form. So that is 3n squared minus 8n plus 4, all factored out. So today we're going to use this skill in order to solve a quadratic. We've been graphing this whole time. Now we're going to solve it. So let's take a look at question number 1. Question number 1 says, let's consider the quadratic equation. We have x squared minus 4x plus 3. Now it says equals 0. So that's going to be a little different than what we had in the do now. The do now, there was no equal sign, but this time it's equal to 0. So we have to figure out what could x be in order for this whole equation to equal to 0. We can kind of guess and check, and that would take a long time. Or we can use our knowledge of factoring to actually figure out what would make it equal to 0. So how do we factor x squared minus 4x plus 3? Can I use the shortcut? Yeah, I can, because there's a 1 in front. So I can go straight to figuring out what multiplies to 3 and adds to negative 4. Again, we have, Again, we have multiplying to 3. So we want to multiply to 3. 1 times 3. But again, we have a negative. 1 and 3 add up to positive 4. We want negative 4. So a negative 1 and a negative 3. That will add up to a negative 4 and multiply to a positive 3. So my shortcut says that I can go straight to this step. And now I'm done. I've factored it. Because x squared minus 4x plus 3 is equal to 0, then we can say that x minus 1 times x minus 3 is equal to 0. We factored this. We wrote it in a different way. Now, because we factored it, we can use something called the zero. I'm gonna write it on the side. We're gonna use the zero product property. And that basically says that if I have A times B, any number times anything else, and if that equals 0, then that means that A could equal 0, or B could equal 0, or both of them can equal 0. And that's kind of like what we have here. Like this is our A, and this is our B, and we're doing A times B equals 0. So that means that we can break these up. And we can say that either A or x minus 1 equals 0, or we can say that B, x minus 3 equals 0. And we can solve these smaller equations to figure out what x can be that would make the whole thing equal to 0. So, well, how do we get rid of a minus 1? Well, we add 1 to both sides, and x equals 1. So when I plug 1 into the equation, I could get 0, and I add 3 to both sides here, and I get x equals 3. 3, if I plug in 3 into the equation, I'll also get equals 0. So what are my solutions? My solutions are x equals 1 and x equals 3. Okay, which kind of has to do with something like factored form. If I go into my calculator and I graph y equals x minus 1 times x minus 3, I'm going to get this parabola that's going to be concave up, 1, 2, 3, and it's going to hit my x-intercepts at 1 and positive 3. Those are my x-intercepts. So my solutions are my roots, my x-intercepts, my zeros. Another reason why they're called zeros, because we had to set the equation equal to 0 in order to find them. Okay, so that's what we're actually doing when we're solving these equations. We're finding the x-intercepts. That's why we're factoring them. Remember factored form, one of the key features was the x-intercepts? That's where it's all connected now. So you can always check this in your calculator, and the roots, the x-intercepts, should match up. Okay, let's keep going. Let's try another one. All right, in question number 2, this equation is a little different. It's not equal to 0. You see how it's equal to 9 here? This one is different, and it also has a 2 in front. Okay, so why is this one different? This is different because this is not equal to 9. This equation is not equal to 0. It's not equal to 0. It's equal to 9. And what is a root? Okay, a root is a 0 or x-intercept. So we can't solve this equation the way it is. We have to get it equal to 0. That is the only way we can use factoring to solve it. Okay, because when we factor it, we're finding the x-intercepts, and the x-intercepts are the zeros. So for this equation, what we're going to do is we're going to make it equal to 0. We're going to subtract 9 from both sides. And when you do that, you're going to get 2x squared plus 3x minus 9 equals 0. And that's the equation we're going to use to help solve it. So that's the one that we're going to factor. Okay, so just like the do now, question number 2, on the do now, in order to factor it, we have to multiply 2 times negative 9. So we want it to multiply to negative 8. We want two numbers that multiply to negative 18 and add to 3. So I'm going to play my game. Multiply to negative 18, add to positive 3. So negative 18. We got 1 and 18. One of them has to be negative. We've got 2 and 9. We have negative 3 and 6. And then we've got the opposites. We got negative 18 and 1, negative 9 and 2, negative 6 and 3. Which one of those pairs add up to a positive 3? This one, right? So we want to use negative 3 and a positive 6. And we're going to split that middle term. So 2x squared, I'm going to put the 6 first. 6x minus 3x minus 9. All right, reason for that is so I have a GCF over here. GCF is 2x. X plus 3 is left over. GCF in the next one is a negative 3. Another x plus 3 is left over. And I get x plus 3. And then 2x minus 3 left over. Perfect. So that is the factored form of 2x squared plus 3x minus 9. All right, so because that's going to be equal to 0 now, sorry, that 0 got left out, then we can say that x plus 3 times 2x minus 3 equals 0. Okay, that's the factored form of 2x squared plus 3x minus 9. So now we can, again, we're going to use the 0 product means multiplication, 0 product property here. And because it's equal to 0, I can say that both of these are equal to 0. X plus 3 could equal 0, or 2x minus 3 could equal 0. Minus 3 on both sides, x equals 3. That's my first answer. Add 3 on both sides, 2x equals 3. Divide by 2. You can leave it as 3 halves, or you can make x equal to 1.5. All right, either one. So what are my solutions? Oh, I forgot my negative here. My solutions are negative 3 and positive 3 halves. So again, we could check this in our calculator. We could graph y equals 2x squared plus 3x minus 9. Take out your calculators if you have it. When we graph it, guess what? Our x-intercepts are going to be at negative 3. And then right in between 1 and 2, 1.5. Our parabola is going to go down, come back up, concave up. And those are our roots. Those are our x-intercepts. Okay, so nothing really terribly new here. I'm just showing you that factoring will actually help you solve a quadratic equation. No more linear equations. Now we're doing quadratics. So we're going to use the 0 product rule and factoring in order to do it. All right, let's kind of tie this all together now. Solving a quadratic by factoring. Step number 1, set your equation equal to 0. You're going to use inverse operations in order to do that. In question number 2, we had to subtract the 9 from both sides to do that. Get the equation equal to 0. Then we want to factor the non-zero side. So we're either using GCF, we're using dots, we're using the X game, right? All of those methods. Then we're going to set each factor equal to 0. That's that zero product property I was talking to you about on the previous page. We're going to apply that, and then we're going to solve each equation, and we're going to get our roots, our x-intercepts, excuse me, our zeros. All right, let's try a couple more. First one, I want to make sure you have time to copy it. First one, question number 1. It's not a trinomial, so we're not playing the x game here. There's no GCF, but I hope you realize by now that that is dots, difference of two squares. So how do we factor the difference of two squares? We're going to factor it x minus 4, x plus 4. It's already equal to 0, so first step was taken care for us. Second step, factor. Third step, set each factor equal to 0. So we're going to break these two up, and we're going to set it equal to 0 and solve. So plus 4, x equals positive 4, minus 4, x equals negative 4. Two ways to check it, guys. Either graphically, or I'll show you how to do it algebraically as well. Okay? All right, so graphically, we're going to plug y equals x squared minus 16 in your calculator. not the equal 0. We're going to put y in there. We're going to plug it into our calculator, and you should see x-intercepts at negative 4 and at positive 4. Your parabola is going to go something like this. All right, and that's how you check. You're looking for those zeros. Algebraically, x squared minus 16 equals 0. I'm going to have two checks here because I have two different answers. I plug 4 in, and I check to see if it's equal to 0. 4 squared is 16, not 8. 16 minus 16 is 0. 0 equals 0, check. Then I plug in negative 4, my second answer. Negative 4 squared is also 16. 16 minus 16 equals 0. 0 equals 0, check. And that's how you check to see if you're right. Okay? Second one. Look for GCF. GCF, I see these both have an x. My GCF is x. So that comes out. What am I left with? I'm left with x times x is x squared. I'm left with minus 5 equals 0. Now we're going to split up my factors. Line down the middle. You could put a line across if you want. First factor, set it equal to 0. Second factor, set it equal to 0. Ooh, this is x equals 0 already. I'm done. That was nice. Add 5 to both sides here. X equals 5. Okay. Oh, wanted to show you how to write your solutions. I forgot to do that on the previous question. Your solutions, you could either leave them as x equals and x equals, or we can put little fancy brackets and say 4 and negative 4. Or if you really want to be fancy, you can say plus or minus 4, because that means positive and negative 4. For question number 2, our solutions are two different numbers, so a little less fancy. You can leave it as 0 and comma 5. Notice that I didn't use parentheses. I have those fancy brackets. That means it's a set, a group. There's a group of my x values. Okay. All right. How do I check it? Plug y equals x squared minus 5x in your calculator into y equals, and you should have an x-intercept at 0 and an x-intercept at 5. Okay, and that's how you check. Algebraically, x squared minus 5x equals 0. First plug in your first answer. 0 was my first answer. 0 minus 0 equals 0, yep. That's definitely right. And then we'll plug in positive 5. 5 squared minus 5 times 5 equals 0. 25 minus 25 equals 0. 0 equals 0. All right, one last one, then I'll let you go. This one has no GCF. It's already equal to 0. I'm going to play my game. X game, what multiplies to a positive 1 adds to a negative 2. Only numbers that multiply to 1, 1 and 1. Since I need it to be negative, it's going to be negative 1 and negative 1. So we could use the shortcut here because 1 is in front of the r squared. We're going to write it as r minus 1 equals 0. Split up your factors. Set them equal to 0. Look at this. They're both the same. I wonder how many answers I'm going to get here. Add 1. R equals 1. Look for both of them. So my solution, I only have one solution. It's 1. And guess what the graph's going to look like when I graph? Y equals x squared minus 2x plus 1. You don't have to put r. Keep it with x in our calculators. My solution is 1. And guess what? Our graph only has one x-intercept at 1. Okay, and then when you do your check algebraically, r squared minus 2r plus 1 equals 0, you only have to do one of them because there's only one answer. There's only one number that would make this whole equation equal to 0. 1 minus 2 is negative 1. And there you have it, guys. This is factoring to solve a quadratic equation. Hopefully I didn't go too fast. I will post this video so you can watch it again. Plus, I will post more examples in this lesson as well. So that way, if you want to get a little extra practice on the next page, which I recommend taking a look at, you can copy it down into your notes so you have the whole lesson all filled out. Homework tonight is the review sheet for Friday's test. It will have stuff on it from before this lesson. Okay, so definitely get practicing tonight and email me if you have any questions. Have a good day.